Sometimes you get ellipses that are not centered at the origin, and when they're not centered at your origin, you have to use basically the center of your ellipse is at the point HK, very similar to your parabola and your circle. So if you need standard form of an equation whose has a horizontal orientation, instead of just having an x squared over a squared, you actually have x minus h Kline squared over a squared, and then you have a y minus k squared over b squared is equal to 1. If you have an orientation that's vertical, notice you just flip-flop these two values with your x minus h and your y minus k. Those just flip-flop over here. Then what you do is you go through and find your foci. Your foci, those are always a c value. So this is your c value. The reason it's your c value is because c, c. So then you find your vertices just by using these formulas, and then you find your co-vertices by using these two formulas. So if we want to write an equation for an ellipse with vertices at -6, -2, and positive 4, -2, and co-vertices at -1, -4, and -1, 0, we need to first figure out which form are we going to use. Are we going to use the x minus h, Kline squared over a squared, plus y minus k, Kline squared over b squared, equals 1. Are we going to use that one, or are we going to use where your y minus k squared is all over your a squared? Well, the way to tell is to use your formula sheet to help you out. Notice for your vertices, okay, these are your vertices of your major axis. The values that do not change are your y values. So if you look on your chart and you look for where your vertices, what does not change, well, you have your y values that do not change here, your k values. Looks like here, your vertices, this k does not change. However, if you have a vertical orientation, your k does change. These are two different points. These are h plus a comma k and h minus a comma k. So notice your k values don't change. Over here, your k values actually change because you have an h comma k plus a and h comma k minus a. So what we're going to do is we're going to use this equation for that has a horizontal orientation because your k values do not change. So in order to, the equation we're going to use is right here. And notice you need to find four things. You need to find your h, your k, your a, and your b. These are the four things that will help you write your equation. So h and k, that is just the center of your ellipse. That can be found by just taking the midpoint. You can find the midpoint of either your vertices or your co-vertices, because you're going to have an ellipse that is looking somewhat like this, with a vertex here, and a center right in the middle. So if you find your midpoint of your two vertices, that will give you your h and your k. So if we find the midpoint of -6, -2, and 4, -2, we're going to say -6 plus 4 all divided by 2, comma, -2 plus -2 all divided by 2. That gives us a -1, comma, -2. So this is your -1 is your h, k is a -2. So now to find a is going to be the distance from your vertex out to one of your major vertices. This is your a value. And to find your a, you could use the distance formula from your hk out to one of your vertices, but I think it's easier if you have -1, -2, and you have maybe these two values, that vertex, or maybe you have this vertex. Well, what is the distance that you're going either from -1 to a -6 or from 4 to a -1. Well, the actual distance that you travel is just a 5. So that means that this distance would be a 5, which is your a value. And then finally, we need to find your b value. Remember, your b is the distance from your center to a covertice. So if you're at your center, you have a -1, -2 as your center, and then your covertices are at -1, -4, and -1, 0. Well, what is the distance from -4 to 2? Which should be the same distance from -2 to 0, which would be 2. So your b is a 2. Now that you have these 4 things, you can write your equation by just plugging everything in. So we're going to say x minus a -1 quantity squared over your a squared plus y minus a -2 squared over 2 squared equals a 1. So if we clean this up a little bit, we just get x plus 1 squared over 25 plus y plus 2 squared over 4 equals 1. And this should make a little bit of sense, because if your x is over your a squared value, then that means you have a horizontal orientation, which we do. And then your center is at -1, -2, which is your h and your k. And the distance of your a-axis is 25. Sorry, if a squared is 25, that means a is 5. If b squared is 4, that means b is equal to 2.